Hello and welcome to the third part of my operating system development tutorials. In this part, we'll be focusing on loading a part of the disk into memory so that we have more program space to work with. But before we get into that, we're just going to clean up the file we've already made, because if we add more to this, it's going to start looking kind of messy. So, we're going to want to make a new item. Let's call it print.asm, and we're going to move all of our printing functions and stuff into there. And then, so we can still access it from bootloader.asm, we're going to use a include quotation mark print.asm. Now if we go back to compile it, it should work just as it did before. So no errors, and we run it and we get this is a test string. So now bootloader.asm is a lot cleaner. We have our stack functions and then we print the string, but our string is nowhere to be seen because it's neat and tidy tucked away in this file over here. Now let's move on to loading some data from the disk. So the first thing we need to do is create a new file. Let's call it disk_read.asm. Now we want to define a variable called boot disk, and we'll just make that a single byte. We don't need to initialize anything now. We'll just create this variable. Now, back in bootloader, we need to include disk read.asm, and then we need to move the values of the register DL into the boot disk. We're doing this because when our program is loaded into memory by the BIOS, it stores the disk number that the program was loaded from into DL, so we need to store that for later use. Now, back in disk read, we'll just define a constant program space, and we'll do EQU because we don't want to store this as a variable, we just want a compile time macro. So what this will do is every reference to program space will go through and replace it with this value. So we'll set this to 7E00, and what that'll do is make it so it says 512 bytes after here in memory. So it'll be directly after this. It'll basically just be shoving everything down here. Alright, now we need a function read disk and return. So back in bootloader, we've already included it. So now, after we print the string, we will call read disk. Now, just so that the BIOS knows where to put the new data we read from the disk into memory, we need to define a location. And that's what this program space is for. So we need to move into the B register, the program space variable. Cool. Now, we need to define how many sectors that we wish to read. I'm just going to arbitrarily set 4 sectors at the moment, which will end up reading about 2000 bytes. Now that'll be enough for now, but as our program grows, we're going to have to change this number. So just be mindful that if your program isn't working, maybe it's because you haven't loaded enough sectors. Now, the next thing we need to do is tell it the drive that we want to be reading from. So we move into DL, the value stored at boot drive. Pretty simple. And that's why we stored it earlier, so that we could use it here. Next, we need to tell it which cylinder and head to be reading from. Now, that's hard drive specific things. We don't really need to get into them for the purpose of this video, but we need to move into CH register cylinder 0, move into DH register 0 as well. So this will select cylinder 0 and head 0, just hard drive specific stuff. And we need to read from the second sector. So directly after our bootloader, which is the first sector, we'll start reading the second sector. So we need sector 2. Now, to get the BIOS to read it, we need to do an interrupt. And the code for that is 13. I wrote boot drive here, I meant to say boot disk. Now calling this interrupt, if it fails to read the disk for any reason, it will actually set a special register so that we can actually know when it's failed. Alright, so we can do something like this. We can do disk read error string and declare this as disk read failed. And then we can do disk read failed and fill this up with move bx disk read error string and then call our print string function. And then we can go back up here and do JC. So if it fails for any reason, that register will be set for the carry flag. And then we can jump if it's set to our error function. So we can disk read failed. And this is actually a jump, not a call, so we can't return. We actually can't return from this location. And we don't want to do anything after it fails anyway, so we can just infinite loop. Always remember to null terminate your strings. I forgot to put the 0 there, but I just fixed it. We are expecting it to fail. See, disk read failed. This is because we haven't actually put any data beyond the first sector. So let's do that now. I'm just going to rearrange my files. So I'll make a file sector 1 and we'll put all of this beginning stuff in there. And then I'll create a new file sector 2 plus. And then within this file we can make a new item extended program.asm. And what we'll do is we'll just times 2048. So we'll fill it with 2048 bits, well bytes, sorry. Do these little symbol things. db0. So extended program.asm is just filled up with 2048 bytes. So that'll give us these 4 sectors to read from. So we're going to have to change our compiler options to get this to work now. So we'll open up compile ASM, and we need to, as a matter of fact, we need to compile extended program.asm as binary. So extended program.bin, and we'll change this to bootloader.bin. And what we'll do is on Windows we have a copy command. I'm not sure about on Linux, but on Windows we can copy binary bootloader.bin and then plus extended program.bin, and the output will be called bootloader.flp. Just rename it the same thing so we don't have to change our box configuration. Let's see if that works now. There we go. Bootloader and extended program have been glued onto each other. Now, fingers crossed, we won't get an error. Disk read failed. Alright, what I've done wrong is we need to do a move AH0002, which is the BIOS function for reading the disk. Similarly to how we set it for printing a string, how we set it to 0E, now we need to set it to 02. There we go, much better. So we've read the disk and we've put it into memory. Now, just as a test, just to see if we've read the memory properly, we'll do something like this. So in extended program, we will do db and then we'll do h, lowercase h. And then, after we read the disk, we can do like this. Move AH0x0E and then move AL 0 program space. Theoretically we'll get a H, so we'll do the interrupt 0x10 and let's run that and see what we get. As you can see, we get a H, so we've loaded it into memory properly. And just to prove to you that we have loaded it, we'll remove the call to read disk, compile it again, run it, and we don't have it. So now it's about time we get rid of our test string. We don't need that anymore. Remove it from print.asm and in extended program. Right, to start writing in extended program, we need to set the origin because this is in a new memory space. We need to set a different origin. 7E00, which is what we set it to here. Now, we have to consider that it also doesn't have access to the print.asm file. So what we can do is simply include it, which makes life a whole lot easier. So now, let's write a program in extended space. We want to jump infinite so that we don't just go absolute crazy. And then define a string, extended space success. DB, we are successfully in extended space. Now, I don't know the technical terms for all this sort of stuff, so I'm calling it extended space. You can call it whatever you want, but that's what I'm going with. So now, move into bx extended space success, and then call print string. We need to, instead of jumping infinitely, we can also get rid of this because we don't need to read the single char at the new memory. We need to jump to program space, or whatever we called it, program space. Yeah, so we jump to program space, which will jump to this address, and at this address, our new instructions are there, so we can run the rest of our program. Now let's test it. Ta-da! We are successfully in extended space. Nice! That's exactly what we want to see. So essentially, we started off with our bootloader, we loaded a new program into the memory, and then we started it. Very nice. That'll be it for this video. I hope you kept up. I was probably a bit all over the place at points, but if anything isn't really obvious, just leave me a comment and I'll get back to you straight away. In the next video, we'll be seeing if we can jump into 32-bit protected mode. That's right, we're not in 64-bit yet. When you start out as a bootloader, you're only in 16-bit. So in the next video, we'll jump into 32-bit mode, and then eventually we'll jump into 64-bit mode, but that'll be quite a few episodes down the road. So for now, thank you for watching, and I'll see you next time.